Alright class, in this video we're going to be going over the ideal gas law, looking at how the equation is actually derived, some uses of the ideal gas law, and a sample problem showing how to actually solve an ideal gas law. The ideal gas law equation essentially ties in all the other equations together, and it's a very useful one in order to figure out an unknown variable. The variable will have to be something where it's just initial conditions and not changing conditions. Your ideal gas law is essentially three of the laws we already discussed: Boyle's law, Charles's law, and Avogadro's law, all combined together. So it's a really neat 3-in-1 equation that ties in all of the previous laws. If you're looking at Boyle's law, you remember that your pressure times your volume is equal to a constant. They're an indirect relationship, so when one goes up, the other goes down. Charles's law involves volume and temperature, and that's a direct relationship. Think about the slope of a graph. And we also looked at our combined gas law. That's that P1V1 over T1 equals P2V2 over T2. By combining these laws together, I will get the ideal gas law. Here is your ideal gas law. This is what you see in your formula chart. Your pressure times your volume from Boyle's law is equal to your number of moles times R, which is a gas constant. That's a specific number depending on your pressure, times your temperature. When you're doing these, make sure your temperature is in Kelvin. Always use Kelvin for your temperature unit. The way to figure out Kelvin is you do your Celsius and you add 273 to your number. Here I found an interactive website that actually you could tie in and add numbers in, and I'll actually tell you what the answer is. So if you go to the Calc tool, Calc Chem, Thermochem, ideal gas, I just typed in ideal gas law on Google and it was one of the first ones that comes up. When you change your pressures, for instance, you could actually change the numbers that go with it. So here my pressure was 2, my volume's 30, and my number of moles was 2. These are all the numbers that are listed right here. The temperature is the one we're looking for, and actually gives me a temperature of, zoom in a bit, gives you a temperature of 92.4. So it actually solves the equation for you. Alright, here's a question, a sample question that you have in your learning target. It says if I have an unknown quantity of gas at a pressure of 1.2 atm, a volume of 31 liters, a temperature of 87 degrees Celsius, how many moles of gas do I have? If you remember from the previous unit, you want to do picture kung fu on these. So write down your known and your unknown. Your knowns here would be a P of 1.2 atm. Our V is 31 liters. Our T would be 87 for Celsius, but you got to add 273 to it to get your Kelvin. So when you use a calculator and you add those, you get 360 Kelvin. My R will be 0.0821. This is a number you can find in your formula chart, and it involves your pressure unit of atm. Those are all my knowns. My unknown I'm looking for is the moles of gas. That's my N. Next, we're just going to write the numbers into the equation. PV equals nRT. Your pressure is 1.2. Your volume's 31. Number of moles is just N. R is 0.0821. And my temperature is 360. To solve this, you want to multiply the two numbers on the left. 1.2 times 331 is 37.2. Next, I could multiply the 0.0821 times 360 on the right to get 29.5. I still have N for my number of moles. To solve for N, I'm just going to do the opposite of multiply. I'm going to divide by 29.5. And then when you divide those two numbers, you get your answer of 1.3 moles. Make sure you put your units. Alright class, so that's how you set up your ideal gas law with your equations. Notice that they're all tied together. You have to have your pressure unit in order to figure out what letter you use for R. Any other questions, leave a comment down below or send me an email at kaminskyl@hayescisd.net.